Thanks, Jed. That was great. It's refreshing and entertaining to see such an academic end to the day. But the reason why it's important is because these are the basic toolkits that you will have if you are looking to interface with Speckle data in any form, whether that's through SDK, whether it's on web application development or inside automate functions, let's say. So on that note, let's add this back onto the stage. So this is the specific context that we wanted to talk to you about. Just to go right back to the beginning of the day, I would talk about how an automate function is actually going to be consuming Speckle data. So we said that the automate functions are triggered, or an automation is triggered to fire a function of a model event. To begin with, we've said it's a version being committed, but nominally it could be any event. That model event triggers those automations, and the interface of a model version and what automations will be triggered is controlled by someone we would say that is an automation composer. So it's possible to build your data pipelines without knowing anything about code at all, because you'll be able to consume functions created either by someone in your team or by an external party sharing their functions with you. So if something completely fits the bill, just take it off the shelf. So once an automation gets triggered, it has in itself implicitly an object called the automation context, which is effectively some of the things that you were doing if you were already doing queries on Speckle data. It has all of that information, that kind of legwork for you. It will get you the version data, or in old language, the commit data. And it will also actually keep a record of all of the user inputs that were put in to specify why this automation is particularly unique. That feeds into your function or functions. We're demonstrating one function per automation right now, but obviously the insightful in the comments have already been talking about how you chain these things together. And the function is effectively distinct from the automation. The function is the business logic of actually what you want to do. So in terms of business means what it is that I want to take my Speckle data, what I want to do with it, and how I want to represent it. And one of the things that you'll be doing is pushing back to Speckle. So one of the amazing things I find about Automate is specifically the tight integration between the results of an analysis run on an automation with the front end. So there is this kind of closed box, but a seamless experience of running these results. And all of that is under control of the function author. So the function author is defining what the user inputs were for that function originally, and they're also able to specify all of the different results. And we demonstrated that you say whether it's passed or failed, whether a particular object has a result, and there were artifacts. So we had a Blender renders, we had PDF reports, and also you can actually push a different version to another model. And we can talk about that at a future date. All of that gets pushed to Speckle, and that's that tight integration. So there's a two persona here, the automation composer and the function author. So the reason why it was important what Jed was talking about is because almost all functions will be looking to have a strategy for navigating the Speckle data. And Speckle data covers not only objects, it also has or that automation context has all sorts of other things, user inputs, project metadata, authentication, all the things that are about the automation that's running. But what we're going to talk about is the version object data. And Jed has talked about there are various times you want to traverse the tree or whether you want to flatten the tree. I won't go into detail of what, I won't repeat what Jed's just been talking about. So as you're traversing that tree, or as you're passing that list of flattened objects, what we've learned, or in producing the demos, even though they're quite varied, is effectively there's and to refer back to the if this then that, you wanted to be able to define what the ifs are. As I traverse those lists or that tree, what am I matching against? Am I checking if the object's of a particular type? Am I checking that actually that object has a property Y? If I am I checking the property Y meets certain validation criteria? Is the sill height of that window greater than a meter above the floor? Those sorts of things. Having then done that traversal, following our logic on these checks or predicates, we can then define per object what the action is. And in the context of Speckle Automate, is the actions can be that I'm just reporting. I can report that yes, that property did exist, but it was wildly out of scope. Or I can say it doesn't exist, or I can say that the mesh was too dense. Whatever the checks have already discovered, our actions are then to report or to add a result or possibly mutate the data itself. And it's fairly straightforward to describe. But if check, yes; if not, false, and then you can train these things together. And so this is Python on the screen there. So you can imagine if you're able to define a series of checks, you'll find that actually you'll be doing the same sorts of checks again and again. And it will be, as a function author persona, worth your while to develop your own personal kind of toolkit of these checks. And the reason why that's useful, because you'll be doing it for multiple functions. And that has a representation both in Python and possibly, because this isn't my expertise, potentially a quite verbose version in C#. Technically, Speckle data can be consumed by any programming language. Automate certainly supports any programming language. I've focused on these because we have the SDKs to support all of the work that Jed was just describing. Once you have those checks, you can either say there's a singular check, this object matches yes, but you can also compose them together. So is this object of type wall? Is it blue? Is it of 8 meters high? And that's an if and condition. And effectively, anything that comes out at the end of that is true. That's the object that you want to work with. Or you can do partial completion composition, which means I can reuse the base's type. So this is a Revit parameter, and I can define that as a function, which I'm then able to reuse in my script to say, this object, yes, is a Revit parameter. Yes, is a Revit parameter. But effectively, the base check is type of X, and so you pass that value in. And the actions have also kind of an anatomy to them. But I found in kind of the early days of working on what Automate functions look like, you will have an action which is do something, and then you will have an action which is report something. So I've called them execute and report here. And effectively, there will be a potential for at the head of an action object to record its own state. So actually, this is using object-oriented programming directly as a correlation in code to the object that you're traversing. So a report type function, a report action will be say that I am incorrect, I'm invalid, say that I am valid. It might be reporting that directly on that object, or as I said, they're kind of keeping a record of state that can be then consumed later. So the report that you send back at the end of the function is all of these objects are correct, or 75% of them are incorrect. And the other operational action is to mutate objects. So effectively, you're able to say, I have found this object is correct. I now want to change the values inside that parameter. I want to delete the parameter. I want to take the value of this parameter and this parameter and turn the results into something else. And so you can actually use the Speckle objects as seeds to a calculation that doesn't exist in the context of the host applications. Just a little bit of kind of hierarchy and anatomy of a function itself. Hopefully this is readable. Effectively, all of the code on the left-hand side here, that is all that's required for an Automate function. So the first thing it does is say, go find that version object, then do the business logic, which I've got on the right, and then the left-hand side continues then, have I passed, have I failed, and do some reporting on what the objects were. On the right-hand side, this is an example of using the traversal methodology. So effectively, I've defined, is this a Revit parameter? Is the prefix of that Revit parameter forbidden? If so, then the action is get rid of that parameter. and it will go through that traversal and apply everywhere that it finds it without actually having to mutate the tree of data. So my personal takeaways, having worked on a couple of these demos, is it really will suit you and do you well to keep your own libraries. We obviously will, all of our code, all of our functions will be on the Speckle Systems GitHub repo, so you can completely cut and paste what we're doing. Yeah, so I'll hand over there. Effectively, the approach here to be as modular and repeatable as possible, which is just us resharing what is actually good software engineering practice.